All right, everybody, welcome to 3.4 linear programming. Okay, all right, ready to go, Fillmore. Here we go. We are going to tie the stuff that we've been doing with systems of inequalities into application type problems. That's what linear programming is. And so a new word that we're going to use for the solution to a system of inequalities when we're talking about an application is this feasible region. So that feasible region part, that's actually just going to be the solution. So we'll just go ahead and graph a feasible region just to start here. So this really isn't any sort of a word problem, but this is kind of what we were doing in the previous lesson. So let's take a look. Let's graph. We have four inequalities. These are going to be we're going to start to refer these as constraints. And so we have four constraints or inequalities that we have to follow here on this system of inequalities. So x equals 0, or x greater than or equal to 0. That is going to be a vertical line at the x-axis, actually. And I will just graph that here in red. And so any x value that's greater than 0 is going to be to the right of that line. So I will go ahead and just use arrows. I'm not going to shade the whole time because it would get awfully messy if we shaded everything. Let's go ahead and take a look at the next one, which is y greater than 0. We usually end up using these constraints because oftentimes when we're applying math, we're talking about actual numbers of something, and a lot of times we don't use negatives. So we're talking about ordered pairs, x and y values here that are in the first quadrant, the upper right only. We are also restricting y to be no greater than 7. So less than or equal to 7. So if I go up to 7, see 2, 4, 6, 7, I cannot be any taller than 7 here, any greater than 7 for the y. So that's going to be then below here. So you see how my arrows are starting to give an idea of where we're talking about. So we're to the right of the red line, above the green line, and below the purple line. And then the last inequality or constraint would be the y less than negative 2/5 x plus 6. So this one here, we'll do this in blue. This is in slope-intercept form, so I'll go ahead and start with my intercept, my y-intercept 2, 4, 6 up here. And then that will have a slope of negative 2/5, so that's going to go down 2 and to the right 5 each time. So down 2 to the right 5, down 2 to the right 5. And that is strictly less than, so that has to be a dotted line. So I'm going to go ahead and get my dashed line here. And that's going to be a dashed line. So points on this line then are not included, and that's not the greatest. So let me just fix that a little bit. Some of my points are off. There we go. That'll work. And then all y values, say it's y less than negative 2/5 x plus 6. It's all where are the y values less than the line, I guess you could think of this. And where the y values are less than the line are down below the line here. So now we kind of have this triangle that is going to be our feasible region or our solution to the system. And I can shade that triangle in. I'll shade that triangle solution, that feasible region. If you have your pencil, you'll probably take your pencil and color that in or something. I'll take a highlighter here and we'll just shade that in. So the region I'm talking about is this triangle right in here. This is our feasible region, which we used to call the solution, but now when we're applying it to word problems, we'll say feasible region. So any point in there, in that gray area, will satisfy all of these inequalities here. Okay, so we are going to apply that to an actual problem on the next slide. So here we have another actual problem, and we need to, from scratch, we need to write our constraints. And to do that, we'll need to define some variables. So let's take a minute and read this. Farmer has 10 acres to plant in wheat and rye. He has to plant at least 5 acres. Okay, so at least 5 acres. When you read math problems, you oftentimes will have to read it a few times, but there's certain parts that you got to really pay attention to. At least 5 acres, that sounds to me like a restriction on something. Oftentimes with real problems, you are restricted by things like time, space, cost. So that would be a restriction there that he has. And actually the first sentence, a farmer has 10 acres. That's also a restriction. He's got 10 acres to plant, and he has to plant at least 5 of them. So there's 2 restrictions right there. He's going to be planting acres of wheat and rye. And he only has $1,200. So here's another restriction. He only has $1,200 to spend. And each acre of wheat, so wheat costs $150, and each acre of rye costs $100 to plant. So what we're going to do is we're going to create a feasible region using these constraints, and then we are going to maximize this is a equation we're going to write here in terms of the profit that he will make. And so what we're going to do is we're going to look to maximize that farmer's profit. And I guess the fancy word that your book uses for that is the objective function. So if the profit is $500 per acre of wheat and $300 per acre of rye, then he wants to know what's the best scenario. What should I go for? What's going to make me the most money? All right, so let's go ahead and write some constraints. So constraints, that's the fancy word for the system of inequalities we're going to eventually have. And to do that, we need to write some inequalities essentially. And to do that, we need some variables. So in looking at this, the variables that we're going to need are, and this usually is given away by the last sentence. What are we trying to figure out? That last sentence will usually tell you, hey, what are you trying to figure out here? Okay, and if you look at the last sentence here, I'll highlight this in orange. How many acres of each should be planted to maximize profits? How many acres of each? So I'm talking about variables here for how many acres of wheat and how many acres of rye. So I'm going to need to define some variables. So let's just say maybe W is going to be acres of wheat, and then R is going to be acres of rye, because those are the things that vary, and those are the 2 things he needs to figure out what he's going to do. And then there will be one other variable that's going to be P, which is in terms of P for profit. How much money is he going to profit from however many acres of wheat, what combination of acres of wheat and rye based on his constraints. All right, so I'm going to have to stop here and pick up on part 2 because I'm getting close to my 10 minutes. So I'll stop here and then tune in for part 2.